Hey guys, it's Miss C as a cloud again today because today is day 2 of talking about weather and clouds. I hope that you went outside and checked out some clouds because yesterday was a beautiful day and today is also a beautiful day. So before we actually go outside and check out some more clouds, we're going to talk about how clouds form. So here we are back on Climate Kids NASA.gov, and we're going to learn about the formation of clouds now that we know that they are caused or created through condensation in the water cycle. Clouds are created when water vapor, an invisible gas, turns into liquid water droplets. These water droplets form on tiny particles like dust that are floating in the air. So the water needs something to attach itself to. So it attaches itself to dust or tiny particles in the air, and then it is floating around as a liquid. You can hang up a wet towel, and when you come back, it's dry. You set out a bowl of water for your dog, and when you look again, the water level in the bowl has dropped, even though Woofy, I don't know who's named their dog Woofy, not me, has been nowhere near the bowl. Where did the missing water go? It evaporated. That means some of the liquid water in the towel or bowl changed into an invisible gas called water vapor and drifted away into the atmosphere. Notice that evaporated contains the word vapor. You see it right here, vapor. The same thing is constantly happening with oceans, lakes, rivers, swamps, swimming pools, and everywhere water is in contact with air. Liquid water changes into a gas when water molecules get extra energy from a heat source like the sun, or from other water molecules running into them. These energetic molecules then escape from the liquid into the form of gas. In the process of changing from a liquid to gas, the molecules absorb heat, which they carry with them into the atmosphere. That cools the water they leave behind. Here's our picture. Does it look similar? Because I used this picture for one of our exit tickets when we were covering the water cycle and watersheds. So here we have the process of evaporation. We have our liquid water heating up from the sun, so the water molecules are being energized, and they are then going to go up into the air as water vapor. So it's turning from a liquid into a gas. The air can only hold a certain amount of water vapor, depending on the temperature and weight of the air or atmospheric pressure in a given area. The higher the temperature or atmospheric pressure, the more water vapor the air can hold. When a certain volume of air is holding all the water vapor it can hold, it's said to be saturated. So we now know that the higher the temperature, so the warmer the air and the more atmospheric pressure there is, the more water vapor there is. So the more humidity there's going to be. If we are very, very high up in the air, we know that temperature tends to decrease as the higher we go in the air. So it's going to be cold really high up in the air. And so there's less of a threshold or less of amount that the air can hold for water vapor. What happens if a saturated volume of air cools or the atmospheric pressure drops? The air is no longer able to hold all that water vapor. The excess amount changes from a gas into a liquid or solid ice. The process of water changing from a gas to a liquid is called condensation. And when gas changes directly into a solid, it is called deposition. These two processes are how clouds form. Condensation happens with the help of tiny particles floating around in the air, such as dust, salt crystals from sea spray, bacteria, or even ash from volcanoes. Those particles provide surfaces on which water vapor can change into liquid droplets or ice crystals. A large accumulation of such droplets or ice crystals is called a cloud. Hey. We usually think of clouds as being up in the sky, but when conditions are right, a cloud can form at ground level too. Then it's called fog. If you've ever walked through fog, you've walked through a cloud. Although the basic idea of cloud formation is easy to understand, there's much more to learn. Peek beneath a cloud's fluffy exterior and you'll find a world of complexity. In fact, clouds are considered one of the most challenging aspects of climate science. That's because Truly understanding clouds requires a deep understanding of the entire atmosphere. Scientists are working to increase their understanding with the help of instruments such as those on NASA's Terra, Aqua, Aura, Calypso, and CloudSat, and other satellites that observe different aspects of cloud. Here's a picture of a satellite, and it is looking at this cloud and then recording the information to see how this cloud moves, how it was formed, maybe if it's getting bigger or smaller, if it's precipitating. The better we can understand clouds and the atmosphere that creates them, the better we can find out what's happening to our climate.